Okay, let me begin by something you're familiar with. Say we're going to derive this function x squared plus 3x plus 1, and we're going to derive this dy dx. Of course, no problem for you. You will see that this is 2x plus 3. And suppose this is not what you being asked of. What if someone asks you, can you please solve this thing here? And when you see this, you ask yourself, okay, what is it you're asking me to do? Well, basically ask to find, can you find me a function y? So when you derive that function, you get 2x plus 3. So in other words, they're asking you to find y here, but this is slightly different. I'll show you why. Now, of course, you're probably going to do something like this. I'm going to rearrange this dx, and then you're going to integrate both sides, and you end up getting y equals to x squared plus 3x. Now, don't forget the integration constant. Now, do you see a difference here? Here you start off the specific example, we use 1 as the constant, and here is a general constant which you do not know the value of at the moment. So therefore, this is a major issue for us, at the moment. And really, this is also equations. If you think about it, it's the equations, but the equation has one part or some part of it differentiations, and because you're being asked to find the y function, of course we have no choice but to reverse the differentiation process, and that will by means of integrations, and you got this. And this particular form has a name, and because you do not know what the value of c is, you don't know c, right? So this solution, this is of course a solution to the these particular questions, and we have a name for this solution. It's called solution, and it's called a general solution. The reason is we do not know what the value of c is at the moment, so this is a general solution to this problem. Now, what if now we change the questions a little bit here, and we're going to add something new to the end of the problem? And I'm going to do this. I'm going to add something here. I'm going to say that, well, this is the same problem, solve this, but with this extra sentence that given that x is equivalent to 1 when y is equivalent to 5. Now this changed the game a lot. Now this extra condition, and because it's a special condition, we give it a special name. This is what we call an initial conditions, because this is given the conditions, you can now utilize this condition to help you to calculate the value of c. Now, let me write off some part of this. We say we didn't know c, but now we can find c because of this now. So we are right here, we stop right here, but we may now continue because we know that when y is 5, x is 1. So that means we let y equals to 5 and x equals to 1, and that will plus c. Now if you set to this, you will find that c, of course, have to be 1, and therefore you now have another, it's the same solution sort of, but slightly different now. You see there's a solution here, the general solution with the c unresolved, but you have another solution with the c resolved equal to 1. Now, of course, since we have resolved the value of c as 1, it has a name also, and this is called, it's a very specific solution, isn't it? So we give a name to this solution. It's called a particular solution. So let me recap. An ordinary problem But now a different looking problem where the differentiation is given is an equation, and you're being asked to find the function y, and if condition is not given to you, you will, well, integrate this, get this, and this solution is called a general solution because the c is unknown. But if you're given an initial condition like this, and then you can use initial conditions to find the c value, in this case is 1, and so when there's no unknowns like this and everything is known, you can see the coefficients and the constants, and such conditions, such solution is called a particular solution. So this is a particular solution to this problem, and this will be a general solution to the problem if the initial conditions is not given to you.